In this example, we have a block on a plane connected to a hanging block by a rope over a pulley. We're given the masses of the blocks, angle of the plane, coefficients of static and kinetic friction, and we need to find acceleration of the blocks and tension on the rope. So we'll start by drawing free body diagrams. For the second block, we have the mass, a weight pulling down, tension pulling up. And for the first block, we have the weight pulling down, normal force against the plane, tension pulling up. And we also know that there is friction involved, and we need to know which direction the blocks are going to move. So in order to assign a coordinate frame and direction for friction, we need to see which block pulls harder on the rope. So we will compare the tension, the force with which the second mass pulls on the rope is going to be m2g and we need to compare that to the force from the first block. The component that points down the plane is going to be the sine of theta. So we have m1g sine of theta. So then if we compare these, let's see, we know that the g's cancel, so we will compare 30 to 50 sine of 30, which is 25. 30 is greater than 25. So that means that the M2 pulls harder than M1. So direction of motion is going to be down. So we put X that way, Y perpendicular. X follows the rope, so X, Y. And we know that the friction force points against the motion. So now we have assigned friction and coordinate frames, and we can write out the force equations and then check to see if the blocks move. And if they do move, we can find their acceleration. So for block 2, sum of the forces in the x direction equals mass times acceleration equals m2g minus t. So t equals m2g minus m2a. Then for block 1, sum of the forces in the y equals 0, because the block doesn't move off the plane. And that is going to be the normal force pointing up minus component of the weight pointing into the plane, which is the cosine. So n equals m1g cos theta. And we know that the friction force equals mu times the normal force. So we can get static and kinetic. If we put some numbers into here, then we get that the normal force is going to be 50 times 9.81 times cosine of 30, which equals 425 newtons. Static force is going to be 0.8 times that, which is 340 newtons. And kinetic is 212 newtons. So now we can continue and write the x equations. So mass times acceleration in the x direction equals tension pulling up minus the friction force minus component of the weight pulling down. So if we take the tension equation and we put that into here, then we'll have M1A equals M2G minus M2A minus friction force minus M1G sine theta. So we need to check static case to see if the blocks move. We need to see if the weight from the hanging block is great enough to overcome not just the weight from the sliding block, but also the friction that's pushing against it. So knowing that in a static case, acceleration would be 0, we compare 0 to the rest of the forces. M2G minus static force minus M1G sine theta. So here we have 294 minus 340 minus 245, which equals negative 291, which is less than 0. So the blocks do not move. Because the weight of the block that's pulling down, M2, is not great enough to overcome the weight of M1 pulling down the plane plus the friction. So knowing that acceleration is 0, now we can go over here and solve for tension. So in this case, T just equals M2 times G, 294 newtons. So for the problems like this, we start out with drawing the free body diagram. Then we compare which block pulls on the rope more, so we can determine the direction of friction and the coordinate frames. Then write out the force equations, check the static case, see if the blocks move. If they do move, we check the kinetic case, but in this case, they didn't move. So we knew that A equals 0, and we solved for tension from the rope.